Hello guys, welcome to Cheenta School of Statistics and Data Science.
Here, we are provided with a problem with two events, E and F, and we have probability E and probability F and probability E union F complement provided to us. And we have to obtain probability F given E union F complement. So we apply the similar logic here. It reduces to probability F intersection E union F complement divided by probability E union F complement. Now we split up the numerator, which is probability F union E union probability F intersection F complement divided by probability E union F complement. Moving on to the next page. Now this reduces to probability E intersection F divided by probability E union F complement. So now we have to evaluate both the numerator and the denominator from the given information. So now probability E intersection F complement, we are provided with that. So that is equal to probability E minus probability E intersection F. And since we know two of these quantities in this equation, probability E intersection F comes out to be 0.3. Probability F complement is obviously 1 minus probability F, which is 0.6. And probability E union F complement is probability E plus probability F complement minus probability E intersection F complement. Well, we can put in the values. We are provided with two of them and we just obtain probability F complement. So that comes out to be 0.9. And therefore, our required probability is 0.3 by 0.9, which is 1/3. And thus, from the you can check the given options and B is the correct option.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So, in question number 2, we are provided with a function f, which is twice differentiable and increasing with f0 is equal to 0. And we are given that the length of the arc of the curve y is equal to fx from between x equal to 0 and t is given as an expression. And we have to obtain f4. So the arc length is given on the left hand side of the first line, which is root over 1 plus f dash x whole square dx integrated from in the range 0 to t. And the right side is 2/3 into 1 plus t 3 by 2 minus 1. That's what's given to us. So now we apply the, the Lagrange's rule of differentiating under the integral sign. We differentiate on both sides, and that's shown in the second step. And in the third step, we just using the Lagrange rule, we obtain that the differentiation of the left hand side is d dt t into root over 1 plus f dash t whole square, which is equal to 2/3 into 3 by 2 into root over 1 plus t. Like we can just differentiate the right hand side and d dt 1 plus t into 3 by 2, that comes out to be 3 by 2 into root over 1 plus t. So from the third step, d dt t is just 1, and this comes to the fourth step, and 2/3 and 3 by 2 get cancelled, and it ends up as root over 1 plus t. So f dash t is equal to root t. I've written on the next step, and I've also attached a little question why. This is an example, like even if some information is given in the question which doesn't seem very relevant, that might end up being very useful at one step or the other. So f dash t for us is equal to root t. So we just integrate and obtain ft is equal to t to the power 3 by 2 by 3 by 2 plus c. And using the fact that f0 is equal to 0, we obtain c is equal to 0. So ft is 2/3 of t to the power 3 by 2. And f4 is 2/3 into 8, which is 16 by 3. And thus our option is option D. That's the correct option. So
We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey.
This is the question number 5, which we'll be discussing next. So essentially, we are provided with a sequence an, which is greater than 0 for all n greater than or equal to 1. And we're provided with the fact that limit n tending to infinity, an to the power 1 by n is equal to capital L, which is greater than 1. And we have to check which of the following 4 series are convergent. We are provided with 4 series. So we have the given problem. I've written it down in the first line. And now, in these sort of problems, we usually have to go by checking options, because there are, of course, we need, if we don't check them one by one, and since this is an MCQ, once we find that one option is correct, we can actually stop there. But if it's an MSQ, you won't be able to do that, and you'll need to check all the 4 options. So be careful of that. Now we'll be using the given fact that limit n tending to infinity n to the power 1 by n is L, which is greater than 1. So using that fact, we go on to check the options. First, we check option A. Limit n tending to infinity n to the n into n plus 1 into n plus 2 whole to the power 1 by 3n. This is essentially the nth term of the series, and that is equal to limit n tending to infinity n to the power 1 by n into n plus 1 to the power 1 by n into n plus 2 to the power 1 by n 1 by 3. This is just a simple property of the indices. And then we see that just reduces to capital L, which is greater than 1. So we can observe that by the Cauchy's root test, the option A is actually incorrect, and hence we need to go on to check on the next options. We first have next option B. So limit n times infinity n to the power 4 to the power 1 by n. By some simple algebra, that text comes out to be L to the power 4, which is actually greater than 1. So again, this is discarded. Now we have option C, which is limit n tending to infinity root over 1 by root over n into 1 by n, which comes out to be 1 by root L, which is less than 1, since L is greater than 1. Now, since L is greater than 1, then root L is also greater than 1, and thus 1 by root L is kind of less than 1, and this might be a suitable solution for this question. Now we still have to check option D. So limit n tending to infinity n to the power 1 by 2023 to the power 1 by n is L to the power 1 by 2023, which is greater than 1 again. Now, by Cauchy's root test, only summation n from 1 to infinity root 1 by root n converges. So our option C is correct.
Number two, we help you prepare and assess your entrance examinations in statistics and data science, like IIT JAM MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So essentially, we have a function f from R to R, which is defined by small fx equal to x minus 1 into x minus 2 into x minus 5. And we're given capital Fx. And now we are to check 4 options, which one of them are correct or not. So first, we can observe one thing, that the options B, C, and D deal with kind of a similar problem. Like, all of them are concerned with obtaining the extrema of the function, potentially at certain points. And option A deals with an entirely different question. So you should go for the question that's involved in the most number of options. So I went with B, C, and D first. So now we check for the extrema. So I hope you are all familiar with the checking for extrema thing, that when we have a function capital Fx and we're to check for the extrema of the function, we look at the points where f dash x is equal to 0, and then we find the sign of f double dash in those points. So f dash x is equal to ddx and the integral 0 to x ft dt, and using the Lagrange rule again, we obtain it to be ddx into fx. Ddx is just 1. So essentially, f dash x just comes out to be fx. And we can very easily observe that f dash x is equal to 0. That implies x is equal to either 1 or 2 or 5. So these three are the critical points for this function. So next we go on to obtain f double dash x. So f double dash x is just ddx of small fx. So I've obtained the derivative. You can use any of the two methods here, either going for the product rule of differentiation, or you can just obtain the polynomial x minus 1 into x minus 2 into x minus 5, which was what I did, and then just differentiated. And also, I did it for a particular reason because I will be needing this particular polynomial for checking option A. Like in the approach I use for this problem, I'll be requiring that. So f double dash x comes out to be 3x square minus 16x plus 17. And now we simply check the signs of f double dash x at the critical points that are x equal to 1, 2, and 5. I have computed f double dash x and written it down. So f double dash 1 is 4, f double dash 2 is minus 3, and f double dash 5 is 12. So x equal to 1 and x equal to 5 are points of local minima, since f double dash x is equal to less than 0 in these points, and x equal to 2 is a point of local maximum. Obviously, since f double dash x is greater than 0 at this point. Now, let us go by the options. So option B says that f has a local maximum at x equal to 2. So that's indeed correct from the statement I've written here. And option D says f has a local minimum at x equal to 1. That's again correct. Option C, however, says f has two local maxima and one local minimum is 0 to infinity. And that's a wrong statement. So moving on, we now go on to assess the way the function capital Fx behaves, because we have to check in option A that Fx is not equal to 0 for all x belongs to 0 comma 5. We need to check this statement. So Fx is essentially 0 to x ft dt. So I've written down the formula ft dt here. I have multiplied them and obtained the polynomial, and then I have proceeded to integrate it over the definite range 0 to x, and the final expression is here where my cursor points right now. It's x by 12 into a polynomial of order of degree 3. Now, if dash x is equal to x minus 1 into x minus 2 into x minus 5, therefore, if dash x is greater than 0 when x greater than 5, or 1 less than x less than 2, and less than 0 when x less than 1, or 2 less than x less than 5.
To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MS Data Science, check out the first link in the description below.